Hello, class. Today we're going to talk about Kirchhoff's laws and circuit models. Kirchhoff's laws are one of the two of the foundational laws that we're going to use to solve all circuits moving forward. So goals of this section is to be able to describe and identify branches, nodes, essential nodes, and loops. We want to be able to describe and apply Kirchhoff's current law and Kirchhoff's voltage law. We want to be able to use KCL and KVL, as we'll call them moving forward, to create systems of equations and solve them. And then we're going to talk about how to use this voltage and current data to help us model components as resistors and or voltage/current sources. So oftentimes we're going to have complicated circuits. We can actually take a whole circuit board and figure out using just very simple measurements how to mathematically model these circuits. So we can kind of reverse engineering certain technologies. It's kind of cool. All right, let's talk a little bit about terminology. Branches. What is a branch? A branch is going to be any case where we have single two-terminal elements in a circuit. We're not going to count wire. Wire does not count as a terminal element. This is just connector. Nodes are points of connections between two or more branches. Nodes also can be used to kind of model an entire portion of a circuit, right? If you want to, you can kind of draw for lots of wiring diagrams. If there's something complicated, they might just draw a big circle around it and call this is a node, and the node is actually standing for something like, I don't know, an electronics control module, like in your car, right? An ECM is a very complicated piece of machinery, but we could just model it as a node with a bunch of things coming into it. We have essential, and your book calls them extraordinary nodes. Either one of these is the same thing. We're just saying, hey, this is a point where we see a lot of branches coming in, at least 3 or more. And a loop is kind of very generic. We're saying this is any time we see a closed path in a circuit.